In this video, I will be going over the section 6.7 day 2 notes, more on solving equations involving radicals, but as we know, radical expressions can be converted to ones with rational exponents, and that's what we're going to see here. But before we get to these problems, I do have a side note that I want to talk about, and it kind of deals with what we saw on the last video. So in the last video, instead of rational exponents, everything was in terms of a radical, whether that was a square root, cube root, but your steps were to isolate the root first and then remove the root or the radical. So here I would subtract 1. And then I would divide by 2. And then once I do that, I would square both sides since it's a square root. And then I would solve for x. But the other important thing is we had to check our answer. And this is what I wanted to talk about today. It didn't show up in the last video, and unfortunately it doesn't show up a lot in your notes today, so I want to really emphasize this. If I take 10 and I plug it back in, watch what happens. So we know that 10 minus 1 is 9, and we know that the square root of 9 is 3, and we know that 2 times 3 is 6, and 6 plus 1 would give me 7, which is not, right? It is not what we wanted. So x equals 10 is actually not a solution. This problem has no solution because what I found didn't actually check. This is called an extraneous solution, and the reason why it happens is because of this step right here. So if I rewrite this step without the square, hopefully you can see maybe something wrong with this picture. The square root really shouldn't give you back a negative number. We always deal with the principal square roots. We haven't really been using plus or minus. The square root should always give you back the principal square root. So this should be a red flag right here. And by squaring that negative number, it gave me back something positive, which we could easily work with, but we created this extraneous solution because really at this point, there is no value for x that will make this a true statement. The next one here, I have the square root of 5x minus 1 is equal to x minus 3. Well, the square root's already by itself, so I can go ahead and square both sides. This is something that we didn't see as well in the last video, nor does it really come up a whole lot in this video. But you'll notice that while on the left side I get 5x minus 1, on the right side I technically have to use FOIL to multiply that out. When you square a binomial, you need to multiply. So that would be x squared minus 6x plus 9. And then I would need to set this equal to 0. So I'll subtract the 5x and I'll add the 1 and then factor and then solve. And this is where checking your answer is really important because more than likely there might be something in here that doesn't work out. And so I'll kind of show you another way to think about it. Instead of checking the whole problem, check to see what the square root is going to be equal to. Right? So if I plug in a 10, 10 minus 3 is 7. I can take the square root of some number and get back a 7. That's okay. But if I plug in this 1, I get 1 minus 3. And whatever that is, whatever that square root is inside, 1 minus 3 is negative 2. And just like this case right here, I don't want the square root to give me back a negative result. So the 1 is extra, it's extraneous, and it's one that doesn't actually become a solution. So this, while I found 2 answers, only has 1 solution. This is very important, and I know that you don't have this written down in your notes for today, but I would really take a moment, if anything, to make a side note on the top of your paper, and I'll do it real fast here. And you can pause the video if you want to write all of this down. But here's the biggest thing. For square roots or for fourth roots, any type of even root, You don't want it equal to a negative number. It's okay if it's an odd root because you can take, the cube root of a negative number. That's okay. So really, as your side note here, specify those even roots. So we have to be very careful about that. But let's go ahead and continue on here. And this side note might help me check my answers a little faster today. It's going to be the exact same steps. So you're going to isolate the radical, which will be the term with the power. So I'm going to add the 1. And then I'm going to, if this is a 1/4 power, I'm going to raise both sides, and I'll use brackets here. I'll raise both sides to the 4th power. So this would become, so the 1/4 and the 4, if you use your power to a power rule, 1/4 times 4 is 1. They drop out. So this is x plus 2 equals, and then I have 3 to the 4th, which is 81. And so I get a possible answer of 79. So if I plug 79 back in, you just have to check that. So 79 plus 2 is 81. The 4th root of 81. Okay. So if you don't remember your powers, you can do a 4th root like so. 4th root of 81 is 3. And 3 minus 1 is indeed 2. For example number 2 here, the first thing I want to do is I want to get rid of the fraction out front. So I'm going to multiply both sides by 3 to get rid of this. But at the same time, you can also divide by -2. So I'm going to multiply by the reciprocal to get both of these to go away. So this would be x to the 1/5 power is equal to 3. And so then you'll raise both sides to the 5th power, raise both sides to the 5th power, and that's what it says to do in step 2. Raise each side of the equation to the reciprocal power. So if it's 1/5, you're going to use 5/1, or just 5. So that just means x is equal to 243. And so, once again, you would just kind of check this by plugging in that 243. We know that 243 raised to the 1/5 power is 3. And then -2/3 times 3 is -2. So it does check. So I've got 2 more here. Number 3 here, I'm going to subtract the 5. And then I'm going to raise both sides to the 5th power. And so I get 3x minus 2 is just equal to 1. And then I'm going to add the 2 and then divide by 3. So I get a value of 1 here. So that would be 3 times 1 minus 2 raised to the 5th power and then plus 5. So that's going to be 1 plus 5, which is indeed 6. So for the last one here, you want to add the 4 first. And then divide by 2. And then cube both sides. That's the reciprocal. So that's 6x minus 3 is equal to 8. Solve for x. So this is a fraction. That is 11/6. And so when I go to check this, so I've got 2 times 6 times 11/6 minus 3 raised to the 1/3 minus 4. Well, 6 times 11/6 is just 11. 11 minus 3 is 8. The 8 raised to the 1/3 power is a cube root. The cube root of 8 is 2. 2 times 2 is 4. Minus 4 is 0. So really pay attention to these rational exponents and how you use the reciprocal, right? How you use the reciprocal of those rational exponents to remove the power from the equation. But also pay attention to what we talked about at the very start of the video, with the answers that possibly don't work, with those extraneous solutions. Very important problems. But there's your video for today.